Okay, this is topic 7.3, area and volume of cylinders and cones. We've been working with that, so the formulas are not new. We're just going to work with them a little bit differently. Let's review for a minute and do the three formulas we've been working with. Let's write those down. The lateral, LA is for the lateral area, and that's going to be pi. Is this a cylinder? Yeah, I'm sorry. So that's 2 pi RH. Total area is when you do 2 pi RH and you add two circles. So 2 pi r squared. And the volume is pi times radius squared times height. The base area times the height. So let's see if we have all the information. Yeah, the R, let's write this up here. The R is 6, the height, the H is 8. And really that's all you have to know to do these formulas, especially when they want them in exact form. And I know it didn't tell you to on these, but unless it says to the nearest decimal or tenth of a decimal, we're always going to leave our answers in exact form. So let's try the first one. You have 2 times pi times 6 times 8. 2 times 6 times 8 is 96, so this answer is 96 pi. And this is in centimeters, so it's 96 pi square centimeters. Now we already know the lateral, so I'm going to write it as 96 pi. Remember, this is the lateral area, and we already did that. So plus 2 pi r squared, we're going to do the radius squared times 2. So that's going to be 96 pi added to 6 squared is 36. 36 times 2 is 72, so you're adding 72 pi with 96 pi. That would be 168 pi. And again, it's area, so it's square centimeters. For volume, you're going to do pi times 6 squared times 8. It's a pretty easy little formula. 36 times 8 is 288. So 288 pi. And remember, volume is cubic. So it's a cubic centimeter. Alright, that's a review of using the formula for a cylinder. Now, let's do the next one where they've given us, see how it says the volume? They told us the volume. So I'm going to write the volume formula for a cylinder, and under the V I'm going to put 81 pi because that is the volume answer. They've given us the answer, and you don't need to write the inches cubed. That would just confuse you as far as the variables. So don't put the units, just put the answer. And then pi times 3 squared times the height. This right here represents 9 times pi times the height because you square the 3. Now when you divide out the pi and the 9, that'll leave the height. Dividing 9 pi from 9 pi leaves you with 1, and dividing 81 by 9 leaves you with 9. The pi's end up canceling each other out, so the answer on this one is 9 inches. Okay, let's look at example 3. What would be the volume of a cylinder described in example 2 if the dimensions were increased to 1 1/3 times the original length? Alright, I'm going to remind, we have done this before, but let's review for a minute. This 1 1/3 is your scale factor. Now 1 1/3 means the same thing as 4/3 because 1 times 3 plus 1 is 4, so that makes your improper fraction 4/3. So it's 4/3 is your scale factor, and that means it's going to grow, it's going to get larger. Now because it's volume, the ratio volume, or volume of ratios is how you want to say it, you always cube your scale factor. Now when you cube a fraction, make sure you cube the numerator and the denominator. So 4 cubed is 64 and 3 cubed is 27. Now this right here, this is called the volume ratio. And it's got what it means is it's the ratio of the new to the ratio of the original. And I think I'm going to write that. It's the new over the original. Now the reason I know that is because, see, it's a bigger number up here. This is a cylinder that's growing because it's increasing in size. So the larger number will be the one we want to use. Now just set this one up as a proportion. Let me rewrite it over here. 64 over 27 is going to be written as a proportion. Since we know the volume is 81 pi, and that's the original, put 81 in the denominator. Yeah, I think this will work. Let's try it. Okay, so this would be 27, 27 times x is equal to, I do need the pi on that, that would be 5,184 pi. If you divide by 27, just use your calculator, divide 5,184 by 27, that's 192. So it's 192 pi for the volume if all the dimensions are increased 1 1/3. This is cubic inches. Alright, let's try an example 4. Okay, this time we're going to have to use not the volume formula but the area formula. And the total area of this cylinder, and this formula is a little bit longer, but the total area, surface area, is 2 pi RH plus 2 pi r squared. So go ahead and put your 144 pi for your total surface area. The radius is 6, so every time I see the radius in my formula, I'm going to fill it in with a 6. So 2 pi times 6 squared is going to give us this last part. So 144 pi is equal to, this is going to be 12 times pi times height, and 2 times 36 is 72 pi. Now this one's a little bit trickier. Look at the formula. There's a plus sign, so you will need to move this one. Since I want to solve for h, I'm gonna get rid of this last. You are going to subtract your 72 pi first. 144 pi subtract 72 pi is 12. No. Yeah, 72. I was getting ahead of it. Now you're going to divide out your 12 pi. I have to write a little bit smaller. I'm getting to the end of my paper. 72 divided by 12 is 6. And the pi's divide out, so the answer for your height is 6 meters. So really on that one, you know, it's kind of tricky with the pi's. You got to be careful with those. But that's, you might want to study that one a little bit. Make sure if I'm going a little faster than you're writing, that you are going to take a minute and pause the video. That's always going to help you catch up with your notes. Alright, example 5. What would be the total area of a cylinder described in example 4 if its dimensions were reduced to 3/4 their original? Okay, 3/4 means it's going to get smaller. We're still going to use 3/4 as our scale factor, but because it's area, you only square your scale factor. You only use the cube of the scale factor if it's volume. If it's area, you square the scale factor. Anytime you square a fraction, just square both the numerator and the denominator. Now this right here is called my area ratio. And since it's a ratio, we can write it as a proportion. So we have 9 to 16. Now you do have to go back and look at the answer to your total area from example 4. Example 4, it was 144 pi. Now remember, this one's getting smaller, so the original is larger. See how this is a bigger number? So 144 pi is the one that we do know. We don't know the new one that got smaller, so that's how you kind of set up your proportion. Now just cross multiply 144 times 9. Alright, I've kind of run out of room, but let me write it. It's 16 times x. You cross that with that. And then 144 times 9 is 1,296 pi. If you divide that number by 16, you get 81. So the answer, I'll just put it over here, it's 81 pi. That's the new one that got smaller. But we know the ratio of areas is always the square of whatever the scale factor is. The next one is a cone, so make sure you switch formulas now. The lateral area of a cone, I'll write it down here, is pi times r times L, and the total area is pi RL plus 1 circle, pi r squared. So always refer to the formula chart if you've forgotten the formulas. Now that's for lateral area and total area, but look at this word, volume. The volume of a cone is 1/3 pi r squared h. Base area. Now the formula chart says capital B h, but just remember that the capital B is always the area of your base, and since we're looking at a cone right here, let's write that on here. The base is a circle. So that's kind of a hint. You need to be careful for that capital B. You need to always look at the area of the shape that you're working with. So that's why I replaced the capital B with the pi r squared. And don't forget the height. That's part of your answer. Now because they've given us the answer, I'm going to write it under the V. They also gave us the radius, so we can square the 5. Now, squaring 5 and dividing by 3 does not give you a whole number answer, so I think I'm going to leave it a fraction. 25/3. I know it's going to look kind of funny, but we want to get an exact answer, so I'm going to show you how to do that. Now, we know we can divide out the pi's, but when we divide out a 25/3, you're really multiplying by the reciprocal, but if you want to put that in the calculator, just type it in as 100. Let me show you. 100 divided by, let me cover it up for a second, I'm going to just show this to you. It's 100 divided by 25/3, and you will have to put it in parentheses. See how you can just divide by that fraction. Another way to do it is, anytime you divide fractions, you're multiplying by the reciprocal. So watch, if you multiplied by 3 over 25, you'll get the same answer. So 12 is your height. And this is, did they give us a unit? Since they didn't give us a unit, let's use U for units. Alright, this is a slant height. It's kind of a funny, it looks like a 1. Why don't we change that into looking like an L like they do on the formula chart. Now we want to figure out the slant height. For the slant height, let's kind of sketch a picture. I think I'll put it right here. We have this cone, and we already know now that from the center to the vertex point, that's the height, that's 12. Slant height is the one out here. It's going to end up being the hypotenuse of our right triangle. They did give us the radius, it's 5. So this is where you have to do to find the slant height, you will have to use the Pythagorean theorem. Let's do that. So it's 5 squared plus 12 squared. This is actually a Pythagorean triple. It's going to give me my hypotenuse. Watch. 25 plus 144. 25 plus 144 is 169. And 169, the square root of that is 13. So that is my slant height. My slant height's 13. And we don't know the units, so we'll just put units. So for this one, we're going to do pi times the radius 5 times the slant height 13. And 13 times 5, let's make sure I do that right. Yes, 65. So 65 pi square units. I'm sorry, this is getting a little bit sloppy. I think I'm going to write it kind of small under here. It's going to be pi for total area times 5 times 13. Oh, we already did that. Let's try to keep this as neat as we can. That came out to be right here. This was 65 pi. If you square 5, that's 25 pi. So really what you're adding is 65 and 25. 65 and 25 is 90. So the total area is 90 pi square units. Phew, that was a lot. Take a minute to study that. Pause the video if you need to go through all that we just did. Let's try example 7. Another idea, you can always pause the video and work it out yourself and see how close you get to the right answer. That's always a good way to kind of do these. Alright, this one's a little more problem solving. They want to know, they're giving you 2 cones and they want to know which one has the bigger volume and which one has the bigger lateral area. So you will have to do 2 formulas for each. If you'll notice, I'm going to draw both of these. We're going to call it cone A and cone B. Alright, cone B, it looks like, has a bigger radius and a smaller height. So it's kind of real long and short. Sort of like this. So the radius is 12 and the height is 9. And on cone A, it's got a smaller radius and a taller height. So when we sketch it, our radius is 9 and our height is 12. If you notice, even though this one's, they look different, the triangles really are the same triangle, just turned. So it's, if we did the Pythagorean theorem, 12 squared plus 9 squared, this is actually another Pythagorean triple. That's 144 plus 81. Make sure I do this right. Yep, 225. The square root of 225 is 15. So this is a Pythagorean triple. So the slant height on both of these, let's label them as 15s. But you do have to do the Pythagorean theorem to get the slant height. Now let's do both formulas for volume. The volume is 1/3 the base area times the height. So we're going to do 1/3 times pi times 9 squared times 12. This is interesting. Watch. 1/3 times pi times 12 squared times 9. You can kind of already tell, but let's go ahead and figure out both of those. 1/3 times 9 squared times 12 is 324 pi for cone A, and 1/3 times 12 squared times 9 is 432 pi. Hopefully you noticed by squaring the 12 that was going to make that a bigger answer. So cone B has a bigger volume. Now let's do the area. For cone A, I think I can write it over here. Cone A, the surface area is pi RL plus pi r squared. So that's pi times 9 times 15 plus pi times 9 squared. So that's pi times we only have to do lateral area. Let's take this part off. Sorry. Just lateral. I guess it wouldn't have mattered. We would have gotten the same answer, but alright, the lateral area here is 9 times 15. So, wait a minute. Nine times 15. So this is 135 pi. And the lateral area of cone B is going to be pi times the radius 12 times 15. You can already tell this is going to be bigger. 12 times 15 is 180. So which one is the bigger lateral area? B. Cone B has more volume and the lateral area, that curved surface, is larger than cone A. Now it's time for you to work some worksheets on your own. Come see me if you need some help.